everybody, welcome to 5.2 Example A. Graphing systems and comparing their tables are good ways to see solutions. This is what we did last time when we were looking at the two internet companies, and we did some other things with just some equations without any context. However, it's not always easy to find good graphing window or the right settings for the table. If you think about that internet company one that we did yesterday, we went to the table and then we had to try and figure out where are they going to be the same, and we started at 0 and we went up by 10, and we found out we should start at 1,000 and go up by 1,000, and we finally got to 7,000, and then we had to kind of work in from there, and it took a little while. Now we got an answer, but we did not really do it the best way. It's kind of like a guess and check. Let's see if we can figure out how to do this. So it's sometimes really nice and great to use a graph or a table, but sometimes we can maybe use some other methods. So also, the solutions you find are often only approximations, right? Using the trace function in your calculator, that trace function only gives us an approximation most of the time. To find exact solutions, you'll need to work out algebraically with the equations themselves. So one way is called the substitution method. So we're going to try and use the substitution method. And you probably haven't seen that before, but this is a very important method that will help you solve equations when they're in a certain form. All right, so let's look at this problem. On a rural highway, a police officer sees a motorist run a red light at 50 miles per hour and begins pursuit. At the instant the police officer passes through the intersection at 60 miles per hour, the motorist is 0.2 miles down the road. When and where will the officer catch up to the motorist? So part A, write a system of equations in two variables to model the situation. Alright, so part A, I'm going to let D equal the distance from the intersection. Alright, I'm going to let T equal time. Alright, and since we're talking about miles per hour, I'm going to have it be time in hours. Okay, I don't want to have it in time in anything else. I want it in time in hours because then I don't have to worry about changing stuff around. Alright, so it says write a system of equations. So what I'm going to do is I'm going to write, let's do one in blue. Let's do motorist. I really think it's funny that the book said motorist instead of like person driving a car. I always think the word motorist is kind of funny and like makes me think of like the 50s or something. I don't know. Alright, so that motorist, their distance is going to be equal to, well, they're going 50 miles per hour, so it's going to be 50t, but they're also 0.2 miles down the road farther than the police officer. So they kind of have this head start, right? Okay, and so there's the equation for the motorist, and now for the police. Alright, so now we can say D equals, well, how fast are they going? They're going 60 miles an hour, so 60t, and then it's going to be plus, well, when they're at the intersection, that would be at 0. So do you need to do that plus 0? No, we really don't. Alright, so now we have our two equations, right? So let's see if we can just kind of grab those. I'm going to move this over here and see if I can just do, oh, that's not going to help. Okay, so we have our two equations. So now what we're going to try and do is part B, solve the system using the substitution method. Now you probably don't know what the substitution method is, so let's go ahead and do that. So the motorist equation again was D equals 50t plus 0.2. And our other equation for the police was D equals 60t plus 0. I'm not going to write the plus 0 this time. Okay, so what I want to know is when and where will they be the exact same, right? Will they be at the same spot so that the police can say, hey, I'm right where you're at. So that means my distances have to be the same number, right? And if you think about substitution, think about that word substitution. Substitution. You've kind of heard that word in other areas before, right? Substitute teachers. When there's a teacher is absent for a day, we have someone who comes in and takes over, right? If you're in sports and you say, oh man, I'm tired, I need a sub, I mean, someone else is coming in for the same position as you, just that way you can get a rest, right? So those words you've heard before, and that's kind of the same thing. What I'm going to do is I'm going to plug in whatever this D equals into the other equation, right? So I'm going to replace this D should be the same as that D, which is the same as this thing, okay? So I'm going to be able to put in this 60t in for this spot right here. So I can say 60t And then we can say that is going to equal the 50t plus 0.2, right? Because that means how long will it take for this police officer to have it equal the motorist who was speeding through the intersection, right? So what I want to do now is I want to solve for t. Well, I have a t on both sides, so what I'm going to try and do is I want to move this side. I want to get rid of the t on this side because I've got numbers over here, and I want to be able to move it over here. So what I'm going to do is I'm going to subtract 50t. And if I subtract it from one side, I have to subtract from the other. Subtract 50t. And I end up with, well, what's 60 minus 50? Well, that's going to be 10t. And I can say that equals 0.2. All right, good. Then what I want to do is now we can just solve for t. So I have 10 times t. So how do I undo multiplying by 10? Well, divide by 10. Divide by 10. Okay, and then I end up with t equals. And what's 0.2 divided by 10? Well, the nice thing about dividing by 10 was just moving the decimal point over. And since we're dividing, it should be getting smaller, so it would be 0.02. Okay, so you say, does that mean it's 2 minutes? So what we should do if we want to convert this to minutes to figure out how long that takes, because I don't really know how long 0.02 hours is. If I take 0.02 and multiply it by 60, that'll tell me how many minutes that is. So if I multiply those together, I end up with 1.2. Oh, that's kind of a weird 1.2. Let's try that again. 1.2, and that would be minutes, right? 1.2 minutes is how long it takes for the police officer to catch the motorist. Okay. So it says solve the system by substitution method and check the solution. So do we have a solution yet? I have the time, but I don't have the distance. So now I want to know, where are they? How far past the intersection have they gone? Well, does it matter which equation I plug it into? It does not, because both of the cars are going to be at the same place at the same time. So if I look at these and say, which one am I going to be able to multiply by? Which one's going to be easier to use? Well, I would say it's probably going to be this one, because all I have to do is 0.02 times 60, which actually I've already done. So what I'm going to do is, instead of using minutes, what I'm going to do is I'm going to use this number and multiply it by here, because we have this whole thing in hours. So I'm going to say this in red. I'm going to use this one. We're going to say my distance equals 60 times 0.02. Why am I using 0.02 and not 1.2 minutes? Because what we have is we're using this in hours, and originally we had in hours, and this is 60 miles per hour, so this will tell me how many miles we go. All right? So what's crazy is that this is the exact same as this multiplication, just means something different. We have, this would be 1.2 miles. All right? So our solution to this system for part B would be, we could say 1.2 minutes and 1.2 miles. Okay? So then, there's our solution for part B. And part C, explain the real-world meaning of this solution. What does this real-world meaning mean? Well, after 1.2 minutes, the police car and the motorist are 1.2 miles past the intersection. All right, so I'll type that out. So, at 1.2 minutes, both cars are 1.2 miles, it's not 1.23, 1.2 miles past the intersection. And that's the real world meaning for part C. Alright, so there you go, and good luck.